Good morning, ladies and gentlemen. Here in New York City at 5th Cloud Computing Expo. We're into day 3 now of this, 5th show. We're into open cloud ecosystems next. Well, actually just one open cloud ecosystem. If you've wondered what the term resource cloud might mean, or you've heard about it and you just want to clarify it, now is your chance. We're going to have a presentation from Pete Malcolm, CEO of Abiquo. Pete, please unpack that colloquy. What is the resource cloud, sir?
Thank you. Thank you. Thank you. Good morning. Right, I've been told I'm not allowed to stand behind the podium. I'll stand over here. Jeremy wants me to. Good. Thank you for joining us this morning. I'm going to be talking about our vision of where the cloud management needs to go. First of all, let's talk a little bit about some history. And I've got a little timeline here just to remind us of how rapidly the evolution of client-server computing has been. So starting back in 83 is when it all sort of really began. Yes, there were some local area networking systems before that, but really this thing got going in 83, which started the movement away from mainframe computing and into client-server. And that was followed up in 1990 by Tim Berners-Lee, a Brit, founded the World Wide Web. And really for cloud computing, the big start really happened in 99-2000. VMware introduced its pretty revolutionary technology in 99 to start virtualization, initially at the workstation and then later at servers. And in 2000, Salesforce.com was first launched. And here really is the beginning of the cloud, reinforced in 2006 when Amazon starts its web services, and really the cloud starts growing in the last 10-year period. Not always called the cloud, of course, but that's when we begin. So that's all kind of culminated by announcements yesterday that VMware believes its revenue for this year is going to be somewhere between $2.6 and $2.7 billion for one company started in cloud. Over a 10-year period. That's a pretty impressive number. So just bear in mind how far we've come here. 27 years of client-server computing, 20 years of internet computing, 11 years of virtualization in its 1.0 phase, and 10 years of the cloud. And at the same time, we've seen a phenomenal growth in the applications that are actually running the applications that have been computerized. And you can see that, contrast what you do and how much time you spend on your computer now than you did 10 years ago. And there's a hell of a lot more that we're doing now. But the same old IT infrastructure management model that was there 27 years ago is still there now. It's exactly the same model. And that's causing some issues. And the IT organization, the IT infrastructure organization, has needed to keep its arms around provisioning and management of machines. And in two senses, there's two categories of risk they've been trying to take care of. The first is the physical risk, which has been around since the start. The risks are you buying equipment that's cost-effective, all that kind of stuff? You're procuring the right stuff. Are you adhering to the standards that you need to keep as a corporation to make sure your systems all keep running? Are you sure that you're keeping other people from interfering with machines that are not theirs, the physical data center and locking people out? Do you have the right levels of expertise? These are the risks that the IT infrastructure organization has been mitigating. And then when virtual data centers come along, some of those things go away. The procurement side is not so relevant. The standards are a little less relevant in as much of the standard equipment you're buying. Once you've decided on which virtualization technology or technologies you're going to use, you've kind of taken care of that. But you've got risks still of interference with one virtual enterprise interfering with another. That's still a risk that you've got to contain. And you've got risks of exceeding resources. And for that reason, the IT organization still controls everything and has to keep its arms around everything. However, that means that IT is still provisioning all machines, virtual and physical, are still being done by the infrastructure organization. And that leads to a bunch of issues. It leads to, first of all, the issue of virtual machine sprawl. There are now so many virtual machines out there, it's really hard for the IT organization to keep its arms around it, or to keep on top of what's going on. And you've got a real disconnect. The IT infrastructure team are not the people who are responsible for the applications. So they don't know what's going on at the application level. Their job is just to provide these resources. And so, give you an example of how that disconnect is manifested. The virtual teams, when they finish, the application teams, when they finish using a virtual machine, the infrastructure guys who provided it often don't know. And you get virtual machines left out there doing nothing, consuming resource, having resource allocated to them, but essentially doing nothing. They're no longer required. And the IT infrastructure team just doesn't know about it because they're disconnected from the application layer. So if you like, it's the wrong people doing the controlling. You've got a very high effort to provision new machines. There's always been a high effort in producing physical machines, but virtual machines are still being provided by the IT organization, and there's still a queue to get them provisioned. So if you want to do a quick project, a what-if scenario, I'd like to have a server up and running so I could just try this out for a short period, you can't do that. It takes too long. It's like in the old world where, when your IT organization took 6 weeks to procure a new server for you. Well, it's still taking far too long in the virtual world, and that leads to a big lack of agility. And that's purely to do with the load on the IT organization. They just don't have the resources to get that done quickly. They're budget constrained like everybody else. That leads to poor capacity planning and poor utilization. The promise that virtualization gave us, that we were going to make things much more efficient in terms of utilization, hasn't really transpired. And it hasn't really transpired because there are humans in the way. Yes, it's theoretically possible, but the reality is that the IT organization is so overloaded that focusing on getting maximum utilization is, they're trying to get through the day, never mind trying to, ensure that we've got the maximum utilization going on or planning for the future in terms of capacity. So the cost savings that virtualization was supposed to deliver haven't really materialized. We've got a bunch of security and compliance issues around virtualization. It's security and compliance are easier to understand in a physical sense when you actually know where everything is and you know where it's actually connected. But we've got to deal with segregation of if you talk about the banking world, the research analysts have got to be completely segregated from the investment bankers, and their machines are not going to be able to sniff each other to see what the other's doing. Lots of compliance issues around that. Lots of security issues around where is that application running? Is it somewhere secure? Is it in my data center where I'm happy about it? Am I concerned about that it may be outside my data center somewhere, and then that's a problem to me? Some things, maybe a web server, it's perfectly okay for my web servers to be deployed at Amazon, because they contain public data, but I certainly don't want my internal trading data to be outside because I just don't have confidence yet in the security provisions. And then lastly, vendor lock-in is an issue for many people. I won't bang on about that today, but clearly lock-in leads to we've got a high purchasing cost and particularly a very high maintenance cost because lock-in leads to doesn't help the market, kind of a market economy, and drives keeps prices high. So our contention is that the unprecedented growth of applications and the complexity of those applications has rendered the current management model that we have for IT infrastructure unsustainable. In other words, things can't go on like this, and the model must evolve. And that's really what we're trying to talk about today, to present to you a way in which we believe that the model can evolve and achieve what we need. So this vision is a top-down strategic vision rather than a bottom-up tactical solution to an immediate problem. We stepped back and thought, okay, where should management go? How do we solve these problems? Not in product terms, but in sort of strategy terms, and then products follow later. We've done so in a completely vendor-neutral sense. I haven't mentioned my company name once, and I won't do throughout the rest of this proposal. None of this is considered proprietary. We're trying to decide and promote amongst everybody a vision of how we could go forward, how we could resolve these issues, and we're very happy to have buy-in from people or debate with people about whether it's right or not. Not proprietary. we want to talk about solutions to problems. We don't want to spend a lot of time talking about cool technology or about buzzwords. This is not about that. This is about how do we evolve and how do we produce a solution that works for everybody, not vendor specific. We've got the latest, greatest, coolest thing. So here is the sort of Spaceship Vision thing. And let me go and talk you through this. And we hope that other people will, as I say, buy into this model too. And the first thing about this vision is you'll see we've got this thing called the resource cloud, which is sitting between the physical infrastructure, that is the physical machines that might be in your data center or a remote data center or somebody, some hosting provider's data center, or at Amazon who may be providing resources to you. The physical infrastructure is in that outer ring. And it's not just servers, it's networking, it's storage, it's all of those sorts of things. It's the physical infrastructure. And that physical infrastructure is provided to this thing we call the resource cloud. And the resource cloud is just a notional thing. It's all of that infrastructure is provided into that cloud, and the consumers of that resource are the people on the inner grey ring. That's the virtual world, the virtual enterprises, the virtual data centers, the appliances, the machines. They are the people who are consuming that resource. And there is a total separation between the two. The resource cloud separates them. So, for example, when you come to, in a virtual enterprise or a virtual data center, you come to provision a virtual machine, you do that logical task of provisioning the machine, but you neither know nor care where in the physical world it ends up. Now, I say you neither know nor care. Certainly there are some things that you care about. You care about policy-driven issues like, is this data in a safe place? This is my accounting data, so it must be in a local data center. But you don't care about which machine or which rack or, other than for compliance or security issues, you don't care where it is. You don't need to know and you don't care. So when you start a new virtual machine up, the system decides where that machine is going to actually physically reside, which physical server it's going to end up on, or which physical piece of storage you're going to use, or which public IP addresses are going to get allocated to you. The system decides all that for you. You don't go anywhere near a physical machine. And this gives a whole bunch of different advantages. You can see that now that the IT infrastructure organization isn't involved in creating those virtual machines. How the procedure actually works is the IT infrastructure organization creates a virtual enterprise. And a virtual enterprise is just a logical unit. And it appoints for that virtual enterprise an administrator, somebody who's going to take care of that enterprise and be its administrator, the guy who's going to be in charge of it. And it also decides what resource is going to be allocated to that virtual enterprise. And today we think in resources in terms of CPU cores, in terms of memory, in terms of disk storage, in terms of sets of public IP addresses. That's the sort of resource. And we set limits on how much resource you can consume in that enterprise. So maybe we say, okay, here's your enterprise created. You've got 100 CPU cores you can use. You've got 5 terabytes of storage. You've got a couple of gigabytes, a couple of 100 gigabytes of memory. This is your stuff allocated to you. And the virtual enterprise administrator is then in charge. And by the way, that process of creating a virtual enterprise, that's like a 2-minute job. You've done it, you've created the enterprise, and you hand it over to the administrator and say, okay, it's yours, off you go. And that administrator then has a view of the world which is just around that virtual data center. He doesn't see any of the physical side of things at all. He just looks at his virtual data center. When he first gets it, he can see his resource limits, and he will be the only user in that virtual enterprise. But he can then appoint other people to be managers in various different roles. He can appoint them as administrators, or he can appoint them as users, or monitors, or whatever he wants them to be. He can appoint other people in roles that can also exist in that virtual enterprise. And they and he can deploy virtual machines at will themselves. As long as they stay within the resource limits, they can do whatever they need to do. Now, in the center of the diagram there, we've got the next component of this, which is the shared libraries, or a set of libraries. And we've got 3 different tiers of them showing there. We've got a private library which contains virtual machine images that you've created for yourself, that you've saved from your virtual machines. Those are yours. You've got a tier of shared images, which might, for example, be images that are created by the IT infrastructure organization. So say this is our standard Windows 2008 server, and we've got our antivirus installed in it. We've got all the management tools that we have on our standard server build all there. So here in the shared library is that build. Anybody from any of the virtual data centers can say, okay, yeah, I'm going to start with the standard build. And if they want to, the organization can enforce that you can only start from a standard build, or it could let you upload your own virtual images. Again, role-based decisions about how you want that to operate. And lastly, at the top layer there, we've got a public library. And in a public library, you can actually get virtual machine images directly from trusted vendors. And they're available to everybody. And as long as you're happy with the trust relationship, we think that a lot of software will be delivered in future as virtual machine images. You're already starting to see that happening. We think you'll see more of that. And simply because it's much easier to deploy a virtual machine image, you can do it with a single drag-and-drop operation in seconds and have the machine up and running, whereas it's much better than having to go and build a machine, physical or virtual, from scratch, where you have to start with the operating system, then the applications, and you have to get it all running and configured and all that stuff. It takes hours and hours and hours. Here you can do it in seconds. So that's the vision. Let's pick up on some of those points. So there are three key foundations to this model. The first is the separation we've talked about between the physical side of things and the virtual side of things. The second is the delegation of authority from the IT infrastructure team to an enterprise administrator. Okay, we create the virtual enterprise. Here you are. It's yours. That power is delegated. And a third is the automatic allocation. When you decide, or when the enterprise decides to deploy a virtual machine, they don't decide where it ends up in the physical world. Policy decides where it ends up. So the sort of sub-parts of that are the multi-tenancy. So when you delegate, you can have multiple different tenants. So if you're a hosting provider, for example, you can create a virtual enterprise for each of your customers. You no longer have to provision individual machines for them. You can sell them a virtual enterprise with so much amount of resource to it, which they pay for, and they can get on and do the provisioning themselves. So they're no longer tied to individual machines. Similar thing works if you're talking about an enterprise. You can talk about your tenants or your customers are individual departments or groups within your organization, and you can bill them and charge them accordingly to what they consume. We've got the workload policy, which determines how those machines are distributed out amongst the physical side. We'll go into that in more detail. And lastly, at the bottom there, you've got the image libraries. So the separation, as we've said, talks about how the providers can deal with providing infrastructure, whether that comes from local infrastructure they've got, whether it comes from remote sites. So you can manage this on a global basis and have all of your different data centers all involved in the same system. You might get resource from an infrastructure as a service provider like Amazon or others coming along. You might get it from a hosting provider who is going to, if you like, rent some of their computing power to you, which you can use in an elastic sense to add to your resources. And again, the virtual side of the house needs to know nothing about this. It's the physical side of the house that deals with the resource provision. And then on the virtual side, you've got the consumers, which can be enterprises or data centers within those enterprises or appliances within those data centers or individual virtual machine storage and networking. And let me just explain appliances. Our concept of appliances is a set of resources, set of virtual machines or storage or networking that you've put together as a group and that you deploy as a single unit. So a simple example of that might be a web farm. Where you've got at the top, you've got a load balancer, and then you've got a few web servers below that, and then you've got a database underneath that. You can group those together as a single connected unit, put that in your library, and then deploy the whole thing with one drag-and-drop operation anytime you need to. If we talk about delegation again, this sort of graphically illustrates how that really is transformed from virtualization 1.0, where you have an expansion of your virtual machines, virtual data centers. It just expands out horizontally, and this is why it's so difficult to manage. And if you move that to the 2.0 model we're talking about, in the delegation, you can make that as, you can get it as manageable as you want because you're creating a hierarchy of individual virtual enterprises, so it's infinitely scalable, as you see. You just make the pyramid bigger. So it deals with that problem completely. If we talk about the policy-based allocation, the workload I was talking about, and this is a very critical part of it. Remember, the allocation of virtual machines to the physical infrastructure happens completely automatically, but it happens according to policy, and policy is a multi-headed beast. So you've got the obvious things at the top, the functional things. I have to decide, essentially, when I'm going to deploy a virtual machine, I have to decide, based on policy, where I'm going to put it. So the first thing I consider is the physical machine running the right hypervisor for that virtual machine image that I've got? So you can cut out all the ones that aren't running the right hypervisor. They're no longer candidates. Then you start looking at what resources have each of those machines got available. So, in other words, will this virtual machine fit? Then you start talking about standards like security. Is the data that's being represented here data that has to stay inside my corporate firewall, or can it go outside? Dealing with compliance and segregation issues, again, back to the research and investment banking example, I must keep all data that belongs to the research analysts in a completely separate rack, which I know is on a completely separate network or VLAN from the investment bankers. Policy can dictate that. Or it can do it dynamically by saying, I can't put this particular data on the same physical machine that a data from that group is on. Do it dynamically as well as by rack. And you might also consider cost in that. I'm going to say that this particular class of user or this group is going to have their stuff on low-cost physical hardware, whereas this group may have access to high-cost physical hardware. All, again, around the standards that the corporation wants or the enterprise wants to put there. And then you've got operational policies as well. We all know that people, when they deploy virtual machines, almost always overstate the amount of resource they need. Natural thing to do. People rarely understate it. They often overstate it. And that means that you're actually not fully utilizing the hardware that you've got. Well, based on policy, you can say that you want to put an overload factor in there. Exactly like the way that airlines overbook seats on planes because they know some people won't show up. The difference here is that when people, if people do show up, you can dynamically do something about it. You don't have to get to an overflow situation, but you can oversell, if you like, the resource you've got to maximize utilization. And you can state preferences for the enterprise for load balancing, for example. So let me give you two extremes of that. We might want to say that load balancing is to do with if we take an enterprise, for example, we might say, we want to maximize the performance of all of our applications. And therefore, I want you, when you do your allocation, to spread the load of virtual machines as thinly as possible across all of the available hardware I've got. And therefore, you'll maximize performance. If you're a hosting provider, you probably want to do exactly the opposite to that. You want to make sure each physical machine you've got is loaded up to the nines before you go on to the next one. So two different examples of workload balancing. And you might also want to talk about preferences for the enterprise who's actually deploying those machines, whether they want to say, I need this machine in a separate physical data center to that one. I don't care which ones they are, but I just want to make sure that they're putting separate physical data centers because I'm trying to do a resilience model here and achieve resilience and, like that. Or you might request you need particular performance characteristics, or you need this is a database application. I've got to have the storage adjacent to the physical server. Those would all be examples of preferences that would be determined by policy when you allocate the machines. A little bit on stakeholders here. The IT infrastructure team is controlling the provision of resources, we said, maintaining the physical infrastructure, purchasing additional resource as is required to contribute to that cloud, and ensuring that service levels are met. In other words, concentrating on the stuff that they're good at, not dealing with the drudgery of deploying virtual machines. They're also creating the enterprises and setting the resource limits, as we've said, so that they can make sure overall that they have enough resource being put into the system for the amount of resource that can be taken out, so that an overload situation can't occur. And you've got the virtual enterprise administrators who are now in control of their own destiny, controlling the consumption of the cloud in accordance with their limits and managing their own sets of users and delegating the management to others as they choose. And you've got the CIO who can now dictate what the corporation or the enterprise's policy is on how we deal with things like workload and compliance and security. That's all done as a policy up front, and then the system just carries the things out according to that. So the benefits is a vastly reduced load on the IT infrastructure team. They're able to focus on their sort of tasks. We've got increased agility, increased utilization. We can now have what-if scenarios and short-term projects because you can deploy a virtual machine in seconds. And we've got all the security and compliance stuff that we need. This whole model can apply to every kind of application, every kind of enterprise, from the smallest to the largest, whether you want an enterprise and you want centralized management and elasticity and all those things. Whether you're a small development house, whether you're a hosting provider, you can sell this in different models. Whether you're an SME who wants to have no physical machines at all, you can have that physical resource provided by a third party, and then you just get on with accessing the machines and using them just as if they were physically in a data center that you owned. And then we've got extensions to this model. Billing and chargeback is easily achieved, based on whether it's the resources that have been allocated to you or the resources you're consuming. You can choose. And we can take this fully into a model of brokered resource where we end up with a marketplace of resource being provided by a number of people and where you can start dynamically moving your load because the market says that I can get cheaper resource from over here, so you can start moving your loads across. We can add active load monitoring. We can add things like energy efficiency so that I can turn off automatically servers that I don't need, and when I need that resource, I can turn them on, all of that kind of stuff. So really, just to sum up, we've got a model here and a vision which consists of those three major parts: the separation, delegation, and allocation. We've got multi-tenancy, we've got the workload policy, and the image libraries. And we believe that this is the future. It's a non-vendor-specific way. We're happy for anybody else to adopt a similar model, but we believe that this is the future of how we can solve the industry problems. Thank you.
Thank you very much. Thank you, Pete. Microsoft is up next on one of our ever-so-quick